Day.
Lovely.
Yeah, and you know the thing is that we've had the last I'd say 2 to 3 weeks have been kind of disjointed. It's like we have a couple days of school, then there's a day off, or we have a long weekend, or a double long weekend, or something like that, and it's been very difficult to find a rhythm. But starting this week, we're going to have about three weeks, almost a month of rhythm. No days off until November 8th.
November 8th.
Yeah, that's election day. And you guys are off. The kids are off, teachers are not. And then that Friday is Veterans Day, and you're off that Friday. So, yes,
Why is it that we get off for holidays like Thanksgiving, Easter, and the holiday break in December, but we don't get off for Halloween?
well,
Some people have off on All Saints Day, but.
first off, yeah, All Saints Day is another way to call Halloween.
So why don't we get off on that?
Because it's a regional.
Well, I think it could be argued easily from a moral point of view that Halloween is evil. I think that's a very easy thing to argue.
But I mean candy.
Well, you know, if that be the case, I think kids would create 180 Halloweens, and you would never go to school.
That could be it, that could be it.
Yeah, I think from a practical point of view, they don't want you free.
Yeah, people think it's.
They want your time taken up on Halloween so that, you know, the old saying, idle time is the devil's workshop.
Or
Why don't
because
they
it's
have it on
not
a
really a
Saturday?
holiday to celebrate. Like,
I
So
don't
say
know,
you're not
but
able
I
to
personally
celebrate
wish
that
Halloween
celebrates
didn't
All
exist.
Saints Day.
Yeah, people think it's
So-
us. We're the children.
Yeah, I hate Halloween with a passion.
Cause
I
some
just
people
wish there was
celebrate it
more
like
time.
religiously, but we just like go out and get candy, that's why we don't have all.
Yeah, my personal feeling on it is that for like really little kids, it's not a big deal, they don't even have a clue. But when you start getting into the older kids, I think you should have a clue. And I think you should know the origins of it and where it comes from, and then you should make up your own mind if you think this is worth doing or not.
It's pagan, right? Isn't everything pagan?
Yeah, but I also think, here's the other problem, in my opinion, with Halloween that's so terrible. I look at my own life, I look at myself, and I remember the first car I ever bought. I bought in, sorry, I bought this car, and it was a used car, and then the next car I bought after that was a brand new used car. It was only used for a year. And then the next car I bought after that was a brand new car, but it was the only car we could afford, and we only had one car for my wife and I. And then the next car we bought after that was a used car because we needed to get a second car. And then from then on forward, we bought new cars. And we would buy a new car and we would use it for 10 years. And for the first 5 years, we would pay off the loan on that car. And then we would buy a new car for the other one. If the first car was mine, I would buy it for my wife. If the first car was my wife, I would buy it for me. And we'd use it for another 5 years. And then it would just keep rotating so that every 5 years we bought a new car. And I think that before some kids go out on Halloween and decide to egg things and do all the other things that Halloween tends to have associated with it, I think they should have something really valuable of theirs either almost destroyed or destroyed. And then they would realize what it was they were about to do to people's property. And I would hope they would say to themselves, no way, that's not a good thing. It's just not something that you should do. When I was a very young boy, I was a very angry kid, and I used to steal a lot. And thankfully, since I'm about 14, I haven't done anything like that. Well, that's not 100% true. If a certain amount of chocolate chip cookies are presented and available, I might just give in to the temptation to have an extra chocolate chip cookie. But other than that, for the most part, I really don't think I've stolen anything. But I do know that I've had some fishing stuff stolen from me as an adult. Very valuable fishing stuff. And I was very upset when it happened to me. I also know that I used to raid my dad's tackle box when I was a kid, and I'd steal all his fishing stuff so that I could go fishing with his stuff. And then he would go fishing, and there would be nothing that he needed in the tackle box. And the same exact thing happened to me. My sons would wipe me out of my tackle. And I remember getting so upset and then saying to myself, you know what, Bob, you deserve this. After what you used to do to your dad all the time, payback. And I really learned through that just how terrible stealing is. That and a whole bunch of other things. So I think if kids knew the pain of having something valuable that they've worked for taken from them, they would think twice before they damaged something that belonged to someone else, that they had to work very hard for. So I wish everybody had to go through that before Halloween. Another great thing that I've heard said is there are certain countries in the world, like Sweden is one that comes to mind, where every single person when they graduate high school has to go in the military for 2 years.
What?
Every single person goes in the military for 2 years. They don't see active duty, but they get a real wake-up call in terms of what life is like. And the thing that's so good about that, I believe, how many of you guys think you're gonna go to college? College is a whole new game. And college demands academic maturation. It demands that you grow up if you're going to succeed. You guys get it, you know, you look at me and you go, do we really have homework? It was a weekend. Do I have to make up a homework? I was at a music lesson, blah, blah, blah. These are things that in college, they don't give you homework. You don't get it. You have to make up your own or you won't know anything. The whole point behind homework is to give you work that helps you master the material. It's not about wasting your time. It's not about making your life miserable. It's about doing what's necessary for you to master the material. Most of the time in college, you don't get homework. You have to make your own up. You have to work your own way through. Have you ever met someone who served in the military?
Yeah.
The difference between when they went in and when they came out is night and day. They become so much greater a self-responsible human being. So there is a plus side to what Sweden does and other countries when you go in there for 2 years. You come out and all of a sudden it's like, this is somewhat sexist, but you change from a boy to a man. From a spoiled brat to someone who really does say, oh, wait a minute. I remember my son Jimmy was never one to argue with us, never. My older son Bobby would be frontal assault. Everything was a big argument. Jimmy was much more subtle with how he would make his points. So I remember one day coming into the house. A few years ago, the price of oil went up really, really high. And I had to pay a $1,000 oil bill. And I was like, you're killing me here, $1,000. So we used to keep the heat at 68 degrees in the house. I knocked the heat down to 60 degrees. So I come in the house and I see Jimmy. He's got his ski pants on. He's got ski boots on. He's got a parka pulled up over his head with a hat, with earmuffs and gloves on, sitting on the couch watching TV. I go, what are you doing? He says, kind of cold in here. I go, yeah. He goes, can we turn the heat up? No. It's kind of cold in here. Yeah. And I just paid $1,000 for a heating bill, and it's not going to get any warmer. It's cold in here. You made your point, live with it. So he couldn't understand where I was coming from with that $1,000 heating bill. Fast forward 2 years. He's at college at Oswego. Oswego is on Lake Ontario. The other side of the lake is Canada. I call him up on a Saturday morning like I was wont to do. Jimmy, how are you today, buddy? Doing good, Pop. Excellent. What are you doing? Oh, I'm laying in bed looking at my breath. What? What are you doing, Jim? He says, yeah, I'm laying in bed under the covers looking at my breath. I said, Jimmy, you've got to turn the heat up, the heat up in the house. He goes, are you kidding me? We just paid $700 for oil. There's no way in the world I'm turning this heat up. So that's an example of what it's like to change from the kid who mommy and daddy pay all the bills to all of a sudden you got to pay the bills. Like, wait a minute, I ain't doing that. So
That's something that you're actually gonna get sick.
yeah, right, absolutely. I'm like, Jimmy, come on. He goes, yeah, Dad, it's 34 degrees in the house. Jimmy, your pipes are going to freeze. You have to turn the heat on. Why? Jimmy, up the heat to 55. Go with it, Jim. Just work with it. So anyway, this is, so there's a plus side to that system. Now, all of that said, I hope like heck during the course of the year, you get to learn a little bit from the life experiences of the Lindquist family and those I've known and loved over the years, so that you can become, why is this not working here? So that you can become better off at what it is that you do in your own life, and you can get that really successful, self-reliant kind of mindset going on there. And I don't know why my little magic markers are my happy pen. You know, sometimes the best way to fix this is to smack it around like an 8th grader.
That's what my mom does to like every electronic in the house.
Yeah, well, look, we got the little green light. We have stylus connected. There we go. See? Just like an 8th grader. Smack it around, it'll do what you want. Now, all right, simplify by combining like terms. This was what we talked about near the end of the last lesson the other day. Hold on a minute. What we said was, what number is in front of the x? Everybody, what number is in front of the x? Hey, come on, end the game. What number is in front of the x? The whole class said? 1. Because there is literally, right there in front of you, 1x. Now, how many of these parentheses are there in front of you? Hey, how many of these parentheses right here? How many?
2.
What? How many of these things are here?
1.
1. So I put my 1 in front of that, just like I put my 1 in front of the x.
I thought you said.
Now I'm going to distribute to both terms. So nothing affects everything in front of that subtraction symbol. 2n squared minus 5n plus n squared. Now, this I have never understood. Oh my Lord, I'm 53 years old. I've seen lots of mistakes over the years. Every one of you, I think, will get the plus 4n at the end of this. But for some reason that I cannot comprehend, and no student has been able to explain to me why they do it, this should be minus 3n. And every year, I look at kids' papers, and they don't change the first sign in the parentheses. I could put 99 signs there. They'll change the other 98. But for some reason, they don't change the first one. This 3n is what kind of 3n? No, that's a positive 3n. Because you have to look inside the parenthesis. What sign is in front of that 3n? Positive. So when I negate the positive, it becomes negative. Now I can combine like terms. Do my laundry, so to speak, or Papa's bucket principle. 3n squared minus 8n plus 4. Okay? That is an extremely important skill. On your Regents exam, there are very few questions that they will be straightforward about. This is one that they might be. Not guaranteed to be, but they might be. And I don't want to miss this question. Okay? So, next up, solve for x. I'm going to, again, I see the distributing here. I distribute the 4, and I get 8x plus 12. Ah! Now we have this in the equation, so I'm going to distribute that negative sign. Once again, let's go back to that point. Everybody take a look here. Inside the parenthesis, what kind of x is this?
Positive.
So when I negate it, it becomes a
Negative.
negative x, and then plus 1 is 41. 8x and negative x makes 7x, because this is the same side situation. And then positive 12 and positive 1 is plus 13 equals 41. Now we've got it to the standard two-stepper, send in the ground troops, die, 7x is 28, divide by 7, x is 4. Okay? Show of hands for my sake, how many people got 4? Okay, pretty good, pretty good. Tomorrow I want to see you all get 4, because you know that negative is going to be there again tomorrow. That would be the sticking point, I think, for most of you. Anthony?
Oh, yeah. No, oh, never mind.
Okay. Now, I want to take a look at number 3. It says, describe the steps necessary to solve the second problem. And sometimes on the Regents exam, they ask you to do things like this. And there's certain terminology that you want to be able to say. For example, that you distributed the 4 to the 2x and the 3. That you distributed the negative 1 to the x and the minus 1. That you combined like terms. Okay, this 8x and negative x, 7x, 12 and 1, 13. And then you did the opposite or additive inverse, minus 13 to both sides, and then you divided by 7. Okay, now, we're going to kind of go backwards a little bit and then forwards. So today is all about the laws of exponents. And the first thing I did, yes,
For like the steps one, do we have to say like what we distributed and what we?
it's helpful to do that. Now, the laws of exponents are here. And what I would like to do first, I should have said right here. What I'd like to do first is just state what the laws are and state where they came from, so that they make sense to you. And then after that, we'll go about applying the laws, and then the last thing we'll do is come back to that scientific notation question that is in front of you. So, here's law number 1. X to the A times X to the B is X to the A plus B. Now, back when I learned math, the teacher would have walked through the front door and said, X to the A times X to the B is X to the A plus B. I have declared it thus. And I would immediately not want to do anything in that teacher's class. Because it would sound to me like some idiotic rule. And teenagers naturally have a rebellious side. So as soon as you carry on like there's these rules that don't make any sense and there's no logic to them, I don't want to know about these rules. I resist them. But these rules make perfect sense, and the rules are just a shortcut to make your life easier. They're not meant to make your life more miserable. So as soon as a teenager realizes that the rules can make their life quicker, easier, better, and cut homework time, now the teenager has their interest in the rules. So let's go through this. Ready? What we're saying here is if I multiply two monomials that have the same base, namely x and x, I just take and add the exponents. So for example, if I have x to the 5 times x to the 2, rather than write everything out, I could just do 5 plus 2 is 7. Now why this works is easy. X to the 5th is this. X to the 2nd is this. How many x's are there? 7. That's why it's x to the 7. Okay? So if you want to write that out every time, feel free, go ahead. Then you don't have to remember that x to the a times x to the b is x to the a plus b. So you don't have to do it if you don't want to. But you tell me which is quicker. 5 plus 2 is 7 or writing them all out? 5 plus 2 is 7. So it's worth knowing the rule. Next one says x to the a over x to the b is x to the a minus b. So in other words, if I am multiplying, I do the next precursor step. Do you know how the definition of multiplication, do you know why we use the word times for multiplication?
Because that's how many times you're adding it.
That's right. It's how many times you're adding it. So 7 times 3 means add 7 3 times. So I would say to you that addition is the precursor of multiplication. Precursor means it comes before. Likewise, subtraction would be paired with or the precursor to division. So just like even though I'm multiplying these two terms, I add the exponents, now I'm dividing the two terms and I subtract the exponents. So there's a parallel there that can help you remember it. So x to the 6 divided by x to the 2 is x to the 4. Or if I drew it all out, here's my 6 x's there and 2 there, die. And what I'm left with is 4 x's. Okay? So far we have, if the bases are the same and we're multiplying, add the exponents. If we're dividing, divide the exponents. And now we have x to the a to the b, when I raise a power to a power. Well, just like multiplication is repeated addition, exponentiation is repeated multiplication. So like when I do multiplication, I go down to addition. When I do exponentiation, I go down to multiplication. So when I raise a power to a power, I multiply. So x to the 4 to the 2 is x to the 8. Okay? So there are parallels in all of these rulings. And the reason is, if I'm going to square something, it means I'm going to write it twice. So this is x to the 4th, written twice. How many x's are there? 8. Okay, that's why 4 times 2 is 8. Now, the next thing we want to be able to do is take those rules and apply them to problems so that we can do those problems more quickly and more easily and get through our work in a more timely fashion. What's x to the 3rd times x to the 2nd in the whole class said? X to the 5th. Good. Now, in this case, I'm going to multiply coefficients and add exponents. 5 times 3? 15. And then, remember, there's really a little 1 there. N to the 2nd times n to the 1 is? N to the 3rd, or n cubed. Next up, what would we get? I'm going to be quiet now. You're going to do it on your paper. Okay, what are we gonna get here, everybody? Everybody?
Negative 21
Good.
A to the 8th power,
Yup,
B to the 8th power,
nice.
C to the 4th power.
Sweet, you did not lose track of that little one there, nicely done. C to the fourth. The one mistake I'm likely to see on this, some kids will put C to the third, and they'll think there's really a 0 with that first C. It's a 1, don't forget that. Okay, any questions?
Plus, if it was a 0, the C would be equal to 1.
Right, it's always, yeah, exactly, anything to the 0 would be 1 anyway. The C wouldn't necessarily fall in, the whole thing would. Okay, next up, x to the 5 over x to the 2, what is that?
X squared.
Everybody, what do we got?
X squared.
No, oh, is that a 3?
Yeah.
Okay, so squared, good. Next up, negative 20n to the 7th over 10n to the 4th.
Negative 2n cubed.
Good. Is everybody seeing how it's just quicker to know the rules for the exponents? Right? They're logical. They make sense. We showed you where they came from. In fancy math words, we derived them. And then, now that they make sense to us, they're easy to apply. Okay, let's do the last one. I'll give you a second to get that done.
I already got
Okay, what are we going to get? Everybody?
it. 2a to the 5th power, b to the 5th power.
Is that an 8 up top there?
Yes.
Yeah, good. You know, what I'm trying to trick you with here is I kind of want you to say 2a to the 2nd, b to the 6th. I'm sorry, b to the, that's 8 and 3, yeah, that's fine. I'm trying to get you to divide the exponents, and you don't divide them. What do you do to the exponents on that? You subtract them. Good, okay. Now, next step up. N to the 5th to the 3rd. N to the 15th, good. Try the next one. I'm willing to bet a bunch of you get it wrong.
And you're probably
Oh my
right.
god.
But then you'll see your mistake and you won't repeat it anymore. That's a good way to learn. Remember, pop it in the windows. Okay. Now, I think the easy part of this is the exponent on the b. I think everybody will get that right. V to the 12, good. But it's 16.
Oh, I knew that.
You are, this exponent of 4 refers to everything in the, now a lot of people like to call these parentheses. I'm kind of partial to the term package. Because when you pick up a package or you do something to a package, everything in the package moves. Likewise, everything in the package gets to the 4th power. So you also have to raise 2 to the 4th. What's 2 times 2 times 2 times 2? 16.
Can you put 2 to the 4th?
You should make it 16. Okay, do the next one. This one I think you will get right. If you are a little confused as to how to find values of like 5 to the 3rd, you can do 5 and then there's an up arrow key. It looks like this, called a caret key on your calculator. If you hit 5, caret 3, it'll give you the value, okay? All right, what do we get? 125, x to the 9, y to the 12, z to the 3. All right, we'll get back to that scientific notation one later, tomorrow or the next day. It's pretty easy. Hasta la vista, vale con Dios, toodaloo, ta-ta. Arrivederci, ciao. Arrivederci, adios amigos y amigas. Cheerio, garushus, kitafes, hasta la pasta. No, Thursday, I believe.